Hey friends, welcome back to the channel, and in this video let's spend some time discussing about NoSQL or non-relational databases. Well, if talk about SQL databases, the data is stored in rows and columns and everyone knows about it. But in the case of NoSQL databases, it is not the case. And if we talk about the different kinds of NoSQL databases, we got tons of them. We have document DB, we have key value stores, we have graph DB, and unlike relational databases, all these databases don't have that much in common. And that's why NoSQL databases is a very broad generalization of databases. Also, if we talk about the common myth that surrounds databases is that the NoSQL databases scale and SQL databases doesn't. Well, in reality, it is not the case. There are tons of examples where SQL databases scale really well, and there are ton of examples where NoSQL databases doesn't scale that well. So in reality, we can drop some kind of constraints on SQL databases, like we can drop the foreign key constraints or other constraints, and we can manually shard them, and we can achieve the same results of scaling SQL databases as we can achieve in the case of NoSQL databases. So talking about NoSQL databases, there are three main types of NoSQL databases, and now these are the most used DBs, and we'll be talking about this in this video. So first is document databases. Now common examples for this is MongoDB, Elasticsearch. Well, Elasticsearch is mainly for indexing and searching, but it is a pretty common example of document DB. Now, the key features of document DBs is we have JSON-like documents, we have complex queries, like we can do aggregations among the database, we can do partial updates. For example, we have a database, we can pick up a few lines and change them. We have a flexible schema. Now the use cases, we have product catalog or in-app notifications. Now these are the common use cases for the document DBs. And talking about key value stores, the most famous examples are going to be Redis or DynamoDB or Aerospike as well. Now, these are glorified hash tables. Basically, we'll have a key and some value associated with it. So simply we can do a get, put, or delete. Like we need to get the key, we need to put the key and the value in the DB, or we can simply delete a particular key. We have a massive scaling and sharding associated with these kind of DBs. We have only single key operations. That is, we can put out, or we can select a particular key and then we can do any operation on it, but it does not have aggregation or joins as compared to the SQL databases. A common use cases is going to be user profiles. We have a key associated with a user, and from that we can have some kind of operations done on it. Similarly, for session storage or the order details, we have a unique ID in all of these cases, and we have different kind of values, or we can have some kind of JSON in which we'll have all the details. So this is how these things work. Third is the graph databases. Common examples are going to be Neo4j or dgraph. Now, this is a type of database in which the data is stored in a form of graph, and we have nodes and edges, and we can have different kind of graph algorithms like BFS, DFS, or Jacastra, and all of these stuff. But the main point here is that we need to only use this if we are particular that we'll be using some kind of graph algos in our DBs. A common use case for that is going to be recommendation engine or the social networks. So how things work here is, let's say we are on Facebook and we have a person A that is a friend of person B, and a person B is a friend of person C. Now B is the mutual friend of person A and person C. So this is how this graph DBs work, and based on this we can recommend person A and see that B is a mutual friend among them. So this is how the graph DBs work. Now let's go a little bit deep dive into each of them. So first, let's talk about the document DBs. Now here's a common example of a document. Here we have a user ID, the total post. Now in this case, what we can have is a partial update. And what we are going to do is we have to select an ID and increment the total post by 1. So this is how the partial update works. Now the key features is we have aggregation pipeline. We can aggregate uh, multiple parts of the DBs. We have a flexible schema. We have different documents which can have different fields, and it is quite easy to add new fields without migration of the whole database. Third is the sharding comes out of the box, which is pretty common across all the NoSQL databases. And these document DBs are the closest to the SQL databases because we have join operations, we have indexes and transaction, but these are quite limited. But these are closest NoSQL databases to the SQL databases. Now let's talk about the key value stores. So here we have simple key operations like a get, put, and delete. All of this can be done in O1 complexity. We cannot do aggregations or range queries or complex filters in these cases. But the common examples, again, it is going to be like user profile or session data. Now, if we talk about Amazon's DynamoDB story, there's a common problem, which was that when Amazon analyzed their SQL usage, there was 99% of the queries were something like this: select from table where ID equal to this. Now, this is simply like primary key lookups only. So for this problem, the solution that they got is to build DynamoDB, which is simply a key value store where we can simply do ID search. We can get simple key value access. We can have massive horizontal scaling, and we don't need any foreign keys or join operations. So in this case, we have a hash-based sharding, which is from the client will get the user ID, and using a hash operation based on different kind of nodes that we want, we can simply have a hash function, and will then divide the data accordingly. So this is the hash-based sharding. Talking about the graph database, we'll see example as Neo4j, and we can have a social media network as an example. So here is, let's say, Alice follows Bob, and Bob knows Charlie. So this is a simple how the recommendation engine will work and how the data is stored as a graph with the help of nodes and edges in the DB. And we can have so these are the example of the certain queries that we can have in the Neo4j. Now there are a few things that we need to keep in mind. We cannot use it for simple CRUD operations, and it is not for high volume transactions because DBs are not optimized that much. They are more complex to operate, and we need to only use this when we need to have graph algorithms in place. We need to have some kind of shortest path algorithms. We need to have BFS or DFS. We need to have a fraud detection in which we use a cycle detection. So this is the main use case of the graph database. We cannot use it anywhere because it can go quite complex and expensive. Now you can have a look at this table if you need to have a look at each of this database given the different features. This is kind of side-by-side comparison. Now we have understood what are the different kind of NoSQL databases. We have a fair idea about what are relational databases, but which database to use given what are our requirements. So before coming up with any of the database for your requirements, we need to ask few questions to yourself. And based on the answer to those questions, we can come up with a pretty good estimate about which database will suit our needs. And one thing to keep in mind that each database solves a particular problem really well. We cannot use a single database across all our requirements because every database has some trade-offs, and we need to have those trade-offs in mind whenever we are picking up any of the database. So talking about the access pattern, so if we are using simply a key-based store, we can usually the easiest implementation is going to be a key value store. We need to have a complex queries like aggregations, filters, and whatnot. So for that, we can simply use document DB or SQL databases. We need to have graph traversals like in the social networks. The common DB used is the graph DB. Now, what's the data structure about? Is it flexible schema? Is it nested objects? We'll go with the document DB. We have a simple key value mapping, key value store. We have relationships at core. We need to have relationships among the data structures. We need to go with graph DB. So what is the scale? Is it massive scale? We can simply go with the key value stores or the document DB. We have a moderate scale but complex queries. We can go with the graph database. What are the operations that we need? What are the guarantees? We need acid properties associated with. We'll go with SQL databases. Do we need eventual consistency? If it is okay with our use case, we will go with key value stores or the document DB. So this is how you will come up with any of the database that will suit your requirements. You will discuss about the requirements. You will discuss about the trade-offs, and this is how you need to select the database that is perfect for your need. Now let's talk about some of the real world examples. So if we talk about Facebook notifications, the main requirements is going to be that we are going to store notifications per user. We need to have different notification types like in-app notifications, or will be sending some kind of SMS or these kind of things. We need to query, which is we need to get last 50 notifications, and we need to have a flexible schema, like we need to give notifications about like, comments, or shares, these kind of things. And the best choice in this is going to be the document DBs, because we have a flexible schema which comes out of the box. In the case of document DB, we can have partial updates, we can have aggregations, and we can shard by user ID. And second example is the e-commerce user profiles. So let's say the requirements are going to be a huge user base. Let's say 1 billion. We have a simple access for these given user ID. I want to know the profile of that. We have high read-write throughput. We don't need that much complex queries, but simple user ID access. In this case, a simple choice is going to be DynamoDB because it has massive scaling. We can scale it massively given our user base. We have simple key-based access. We don't need any fancy stuff out here. We have enormous sharding, and the latency is quite low because we are simply using a key to get the data. And a third practical example is going to be LinkedIn, which is simple. A graph DB. The requirements here are going to be what are the second or third degree connections, what are the recommendation going to be, what are the shortest path, common neighbors. So these are kind of graph algorithms we can use in these kind of databases. And mostly we have a relationship heavy queries. If this person follows some person B, the post of that person is going to be recommended to person A. So this is how the databases are selected based on the requirements in the real world. Now, the key takeaways for the FANG interviews, it is simply going to be that NoSQL databases doesn't mean that it is going to scale better. It is about out-of-the-box sharding and dropping constraints in the case of NoSQL. In the case of SQL databases, we have document DBs, we have key value stores, we have graph DBs, but in the end, we need to talk about what are the requirements, what are the access pattern, data structures, scale, operations, guarantees, what are our requirements that we need, and what are the trade-offs that we can happily make so that we can have robust application. So in the interviews, we need to justify our choice, not just the features of a DB, but why we are using a specific type of database. What are the pros and what are the cons? What are the trade-offs that we can happily make? So this was a whole discussion about the NoSQL databases and what are the different kind of databases. Hope you find it interesting and amusing. So this was today's discussion. See you in the next one.